My name is John Galleher. I work for the Water Authority up in the Operations and Maintenance Department up in Escondido. I've been here about 20 years. So my main job is to make sure that we never see this. Unfortunately, this is not a picture of our pipelines. This is on the East Coast. These are generally smaller pipelines. They're about anywhere between 12 and 24 inches. Now, we have had a failure at the Water Authority here. This one was in Mission Trails Park in 2006. You can see our pipes, as Chair Hogan and Frank talked about, they are fairly large, and they can have a huge impact. This is a 69-inch pipe built in 1959 at about 120 psi. So the Water Authority's pipelines, of the 300 miles of pipe that we have a split of about 167 miles of concrete or rigid pipe, and then we have 132 miles that's steel pipe. The rigid pipe built from the 40s all the way up to the mid-80s, and then steel pipe was built in the late 50s all the way up till today. Steel pipe is our material of choice. So the first thing we want to do is we want to kind of get a baseline. We want to figure out what the condition of that pipe is. And so starting way back in 1990, we went out and we collected any kind of data that we could on the pipe. Anything from the soil that it was installed in, how it was designed, was it a flexible joint, seismic constraints, if it was in a corrosive environment, anything that would impact the operation of the pipe. We also looked at hydraulics. Is it in a pump system? Is it gravity fed? Because that has a huge impact on the condition of the pipe. Once we gathered all that information, we put it into a big gumball machine and we shook it up and we came out what we thought the service life would be, and then what the biggest impact factors were in San Diego. And these impact factors impact different areas of the country more or less. Down in the southern part here in San Diego, we have a lot of chlorides in the soil, so it's a lot of corrosion that can take place. Some of the tools that we use here at the Water Authority is when the pipeline is in service, obviously there's not much we can do on the inside, but we can go out and we can do chemical analysis, we can do some more soil tests, we can build the database that way. About 3 years ago, for our cathodic protection system, which is a corrosion monitoring system, we started using remotely monitored rectifiers, which actually put current into the ground to stop corrosion, to mitigate corrosion. And that was a huge staff savings. You can imagine going from the northern part of the county all the way down to lower Otay. It's quite a bit of area to cover. And if there's something that goes wrong with the rectifier, we don't know about it until we come back there the next month. So the remotely operated rectifiers really had a big impact on us. Acoustic fiber optic monitoring. We use that on our pre-stressed concrete cylinder pipes, our rigid pipes, which we have about 82 miles, and that's been a great technology that we've been using. And I'll talk a little bit more about that in a second here. Remotely operated vehicles over in Lake San Marcos area. We have taken some ROVs, placed them inside the pipe. We can get sonar, we can get the thickness of the pipe if it's out around. Again, we use that information to determine the condition of the pipe. And also leak detection. I have some information later on in the slideshow here. Talks about how we do leak detection on our pipes. And just so you know, we have less than 2%, we're like less than 0.5% is what our leak rate is here on our large diameter pipelines. So once the pipeline goes out of service, what can we do? Well, fortunately, as Chair Hogan said, our pipelines are big enough, most of them, that we can walk in. So if there's not a technology available to determine that condition, we can walk in, we can document cracks, we can look to see if the joints have moved, we can do surveys on the inside if the pipe has smashed, has there been some kind of an encroachment over the top of us that's caused that pipe to smash, and then we collect all that data. Two other technologies, Electromagnetics, or remote field eddy current transformer coupling is what it's actually called. We use that on our pre-stressed pipe, and what that does is it scans the pipe almost like an X-ray, and it determines how many broken wires there are in the pipe. And the number of broken wires that you calculate then can be used in a structural calculation to determine how much life is left in the pipe and if it can hold the pressure. This next one, magnetic flux leakage, is a brand new technology. It's only been out about a year and a half, and it was started up in San Francisco on the Hetch Hetchy pipeline. And San Francisco was nice enough to let us borrow the tool, and we just got done using it last month with some great success on 5 miles of old steel pipe. So just a couple of pictures here on the in-service tools. This is our just a typical test station on our pipeline. We have over 2,500 test points that we check annually, and that goes into a report, and that gives us an indication of if there's any corrosion activity on the pipe, and if there is, what we're going to do to mitigate it. Here's the remote rectifiers. We have 40 sites. These things, like I was talking about earlier, have been very useful. We've had a couple of cars mow them down, and we know immediately when they're hit because the power goes off and we get an alarm. The other advantage to these sites is with cathodic protection systems, you need to do instant ons and instant offs of all your systems. Now that we can do it remotely, we don't have to have 40 staff out there turning these things on and off by themselves. Okay, now let's get into some of the fun stuff, at least for me. So the acoustic fiber optic system. What it is it uses just a standard 4-glass fiber optic cable. And this cable is so sensitive. When I first looked at it about 6 years ago, it was raining and it sounded like drums beating on it. So what it is, it's installed inside of our pre-stressed pipes. And when the pipe is full, if there's a wire break, it only needs 2 glass fibers. And the break that happens inside the pipe actually sends a pressure wave that the glass can feel. So one glass tells you where it is, and then the other glass tells you how large the event was. And then that all goes back to a data acquisition system. Then if it's a wire break, I actually get an email. It goes to our operations center, and it tells us where it is on the pipe. So here it is. Got a little ahead of myself here. So we have 7 data acquisition systems along the Water Authority. We have a couple down in the South Bay, and then we have a couple up at our Twin Oaks treatment plant that feed all the pre-stressed pipelines to the north. It's an extremely large amount of data, and as it comes in to our operators room, they have to determine quickly whether it's a wire break or it's just an event. An event could be something like, say, a rock going down. We had a rash of events last year down here off of Olympic Parkway, and we thought the pipeline was getting ready to fail. We had gotten down there, and the lock had been cut off our structure, and kids were down there shooting BBs on top of the pipe. So it didn't do any damage to the pipe, but like I said, the cable is so sensitive. So after we collect that data, what do we do with it? The chart on the right, what that shows is those bars are the number of wire breaks that we recorded with the electromagnetic technology. So it's the baseline. What's the condition of the pipe that you know today? So let's say it's got 20 wires that are broken on it. The little push pins, what those are the acoustical events that we then add on to the eddy current breaks so that we can do our structural calculations to determine how much life is left in the pipe. The chart on the left here is just our pipe schematics, and we color code them. Red being a pipe that we want to watch. Green is a pipe that there might be a little bit of damage on it, and then if it's clear, it means that we don't have any damage on it at all. And then these are what we're starting to do now is take the data and actually use Google Earth to help us take a look here. So here this is Highway 15, and this is a project. You can see there's a lot of activity here on this particular pipe, and we're actually rehabilitating it right now. This is down in the Mira Mesa area. There's the Miramar Reservoir on your left, and then going through the Camp Elliott area, and then down to Highway 52. So you can see all the little boxes there. That's damage that we've recorded with the electromagnetics and or the acoustic system. Down through the Mission Trails Park, and down here at the San Diego River, you can see we had a lot of acoustic events. And 2 years ago, we went ahead and rehabilitated that pipeline underneath the river. And then that's a shot looking down onto Jackson Drive. Let's see here. And this is just kind of another view that we use. Again, the Miramar Reservoir is on the right, Highway 15. All of our pipelines there, and then this is just a good shot of the damage that we had recorded up on top of Knob Hill, is what we call it. and then the acoustic events as they happened. You can see there's a date and the time, and the number of wires are broken. So this has been very useful. It helps us do a real quick risk assessment, consequence of failure, what's going to happen. Because we won't always rehabilitate the pipe that has the most wires. We're only going to rehabilitate the pipe if there's a large consequence of failure. So remotely operated vehicles. We've used this technology up in the San Marcos area, putting it in a pipe that wasn't flowing, but it was full of water. So we put it in, we went about a mile one way and a mile back. They used sonar, they gave us out of roundness, they looked for some cracks, and it worked very well. Something else I talked about earlier is leak detection. This technology, they call it Smart Ball. It's a little foam ball, probably about 10 inches in diameter, and you can see inside the technologies there. It can go for about 24 hours. And what you do is you put it in your pipe, you close the valve, and you just let it run down your pipe, and you catch it at the end. And as it's going along, it's listening, and it listens for any kind of leaks. We use it up in the north. Fortunately, we didn't have any leaks, but we simulated leaks, and we were able to find those. So what do we do when the pipeline's out of service? Well, like I was saying, we can walk in it. And so the picture on the right there is two big butterfly valves down in the Miramar area. So we can crawl right through those, and that Smart Ball, that leak detection, can also go right through those valves. This one is a 30-inch pipeline that he's crawling into. He's crawling out of a 12-inch pipeline on the Tridencies line. So part of if you want to work in our group, you have to be pretty flexible. So this, you can see on the top there in the bottom slide, that was, next one here, that was a damage area that we had when there was another pipeline that went over the top of us and they'd hit it. They didn't think they had done any damage, but they had knocked off the mortar coating on the inside, and we had to go in and fix that. The electromagnetics, or the remote field eddy current transformer coupling, there's two coils. The photograph on the left, one coil is an exciter coil, and the other coil is a pickup coil. What it does is it treats the pre-stress wires kind of like a toaster wire, or like an antenna. If the wires are all intact as you're going along, you get a very strong signal. If there's broken wires, then of course you lose your signal. And you can take that data, compare it to your shop drawings, and you can get a length of signal that you've lost, and then you know how many wires are broken, and you use that in your structural calculations. When the technology first came out in 1998, we wanted to make sure that it worked. So after our first scans, we went out and we dug up some pipe where they had felt there was some damage. And this is 4 pieces of pipe in the Rancho Penasquitas area. And as you can see by the chipped areas, take my word for it, those are corroded areas on the pre-stress wires. So so from 1998 is when we really started using the eddy current. We've used eddy current on all 82 miles of pre-stress at least 2 times, sometimes 3, to kind of build our failure curves, or our decay curves. The next technology that we're starting to use now on our steel pipe is the magnetic flux leakage technology from San Francisco. And the way it works on the steel pipe is it has, you see the brushes and the magnets, and those are actually right next to the mortar coating. This technology isn't new. It's been used since the 50s on oil pipelines that don't have mortar lining. So the big breakthrough for us now is our pipelines have a mortar coating, somewhere between 1/2 to 3/4 of an inch. So a company in Utah was able to develop this technology for water pipes, and it's a huge breakthrough. The magnets induce a field, and then there's a floating sensor that determines the magnetic flux that's there. If there's not any metal loss, so if it's a 1/2 inch pipe and it's a 1/2 inch between the magnets, you don't get any loss. Let's say you get a 1/4 inch pit, excuse me, it picks up that pit, and it's very accurate. The advantage to this technology is not only does it tell you longitudinally on the pipe where it is, but also radially where it is, and that makes it a big lifesaver for us here. There's a picture of it actually installed in the pipe. It takes about 2.5 days to put together because it has to go through a 20-inch manhole. So it's kind of like putting together Tinker Toys. Now, kind of the fun part of this job is there's these 2 electric ATVs that go inside the pipe. There's one in the front and there's one in the back. I apologize for the dark picture. And they basically, one's pushing and one's pulling. And this thing is very heavy, about 2,500 pounds. And on the steeper hills, what we had to do is actually have a contractor help pull us it up. So after we got the data back here, and this was just actually 2 weeks ago, we dug up a piece of pipe, and it found the damage, and you can see the pits that it had. It thought it had about 40% wall loss, and that's what we were able to measure on this steel. So this is a very promising technology. I think the water agencies that are here that have steel pipe, you're going to start hearing about this and might want to use it. So rehabilitation and repair. What do we do once we find something that we have to fix? We have quite a few steel replacement sections that we've purchased and strategically put around the county. Down off of Highway 54, we probably have, I think it's about 20 sections of pipe, generally lower pressure pipe because our pressure is lower in the south. And then as we start getting up north, we have over by our Twin Oaks treatment plant, over up on Rainbow, we have some thicker pipe because generally we have higher pressure pipes up in the north. So we have replacement sections just in case if there's an event that we need, whether it's a 2 or 6 month event, we do have replacement cans that can be used. Now we don't know what diameter is going to fail, so we've created these rings so we can take a 96-inch replacement can and use it on a 69-inch pipe in an emergency. So one of our repair technologies will be just to take the pipe out and put in a steel piece of pipe. Another repair scheme on the pre-stress lines is we use the existing concrete pipe as a tunnel, as a hose pipe, and then we just build a brand new pipeline right inside. The only disadvantage to that technology is you do lose a little bit of your diameter, so you lose a little bit of capacity, but not much. Somewhere between about 3 to 6 inches in diameter. This picture here is if we're in an area where it's a long way from a structure or it's an environmentally sensitive area where we can't go out and dig it up, this is carbon fiber technology. This is the same technology that Caltrans uses to wrap around the bridge supports to keep them from breaking in an earthquake. So basically we just go in, we water jet the concrete to get a good profile so it'll stick, and then you just get a bunch of guys in there, you just like wallpaper in the pipe. And depending on what the pressure is, it depends on how many layers you have to put on. This is just to kind of give you an idea of the 82.5 miles of pre-stress that the Water Authority has. We've relined to date about 33%. The initial program is to hopefully reline everything up until about 2035. But with these new technologies that we're using, the acoustic fiber optic and the electromagnetics, we may be able to stretch that out a bit, get a little bit more life out of the individual pipe sections. The technology that wasn't there when we started this program, so we're hoping to maybe stretch that out a bit and make the money last a little bit longer. Just talk a little bit about the maintenance. You can see we have a very, very large valve. This is a 90-inch valve up in the Twin Oaks area on the right-hand side there. So these valves have to be maintained once a year. They're greased, they're exercised. Over on the left-hand side, this is a flow control facility actually at Sweetwater's yard. And the older flow control facilities are very tight. So there's a meter in here and there's a control valve, and we're in here doing some welding. There was a little hole that we'd found in there, so they patched it up and repainted it. Dams and pump stations. The picture on the left is a diver going down in a basket. He's going to go down and clean the fish screens. So that's something that we have to take care of. We've got to make sure the fish screens are always clear. And then the picture there on the right, that's we're replacing a bearing over in the Leavenhain pump station. So we have very large pumps, as Frank talked about. We have very large valves, very large meters, all things that have to be maintained on a daily basis. Something else that we have to worry about as well is how we manage our right-of-way. As I spoke of earlier, when there's encroachments, and it could be a driveway, it can be another agency, it could be a homeowner digging around the pipe. If they're not sure, if they don't call a dig alert, we're supposed to have 4 or 5 feet of cover on our pipes. But sometimes they don't understand that, or they'll be putting in a new driveway, and that's exactly what happened here. Fortunately, this is a welded steel pipe with welded joints, and a homeowner put in a new driveway, and he had ripper bars on the back of a D6, and he drug it over the top of the pipe. He didn't know what he hit. He thought he hit a rock, so he just moved his driveway down a little bit, built his driveway. Well, we hadn't been in this pipe since. It was installed in 1959, and we didn't get in there. I think it was about 1995, and that's when we found it. All the mortar was gone off the top of the pipe. But fortunately, the good thing about corrosion is once corrosion gets on there, as long as there's not a lot of water flow going by, it kind of protects the pipe. So here's a picture. The yellow line was the cover prior to the 1990, and you can see how he just kind of came in and he cut his driveway. And right off to the right there, that's the top of the pipe that he thought was a rock. And it was, so fortunately, it didn't leak, because it is quite high pressure here. And with that, I'd be happy to answer any questions.